Today we are going to start with the chemistry chapter of class 9th, that is chemical bonding. So after completing this lesson, the students will be able to understand how molecules are formed or what is a chemical bond. They will be able to explain the octet rule, draw Lewis dot structure, understand the different types of bond, and differentiate the characteristics of ionic, covalent, and coordinate bond. They will be able to understand the redox reactions and find out the oxidation number of different elements. The introduction part. So here you can see that a flower is being held with the help of a thread. So various flowers are being held with the help of a thread. Similarly, various atoms will form a chain like structure with help of bonds. So that kind of bond is known as chemical bond. So atoms held together with the help of the bond. So the bond formed between two or more atom, the force of attraction between the atom that binds them together is called a chemical bond, and they form a molecule by binding together. So for this we are going to see what are the approaches of chemical bonding. That is, first is Cauchy-Lewis approach, where you can study about the octet rule first. So octet rule is nothing but the shell. If you take the structure of atom, here is the nucleus where you have proton and neutron, and here in the shell orbits there are surrounding of electrons. So the shells will be in the nature of K, L, M and N. So these are the shells present in the atom. So each shell carries electrons, and this flow of electrons is responsible for the electricity too. So the electrons are filled in a rule, that is, the first shell or the first K shell will have or should have 2 electrons. After that 8. L shell 8. Then M 8. So this 8 should be there present. 8 number of electrons should be there present in the orbit. That rule is known as octet rule, and this octet rule should be satisfied only then the atom is said to be stable. Fine, can you understand? So here are some common questions, that why do atoms combine, or how do atoms combine, why do certain atoms combine while other not. So to answer such questions we need to understand the Cauchy-Lewis theory. So he gave a wonderful explanation based on the concept of electronic configuration of noble gases. We know that the noble gases are the stable elements. So they are least reactive because they have an octet complete. So every other elements should have the stable configuration just like that of the nearest noble atoms, right? Helium, neon, argon, krypton, xenon, radon. So if you see their atomic number, how their shell is being figured out, the outer shell is combined, is satisfying the octet rule. That is, the number of electrons in the outer shell is always 8, right? So except helium, all the noble gases have 8 electrons in their valence shell. So 2 is also valid because that is the only helium is the only atom where the number of electron present is 2. Even that is said to be a noble gas. Now, based on the noble gas configuration, Cauchy and Lewis proposed theory in 1916 to explain the chemical combination between atoms, and this theory is known as electronic theory of valence. So the tendency of atoms to have 8 electrons in the valence shell, known as the octet rule or rule of 8. So only then the atom is said to be stable. So in case, there are two cases or two possibilities where a valence shell, this is one and this is one another atom. So valence shell, there can be either 8 lesser than 8 or lesser than 4 or greater than 4. So to make it complete of octet rule, here there is gain of electrons to complete the octet rule, whereas here there is loss of electron, where the octet rule is more, where the valence electron is more than 8, then there is loss of electron in order to make it 8 and complete the octet rule. So you will be understanding this more clearly with examples. So here sodium is having an atomic number of 11. So you can write it as 2, 8, 1. So one electron is extra, that is the one electron should be loosed. Only then it can become a stable atom, right? So the sodium, which is having atomic number 11, has an electronic configuration 2, 8, 1. So in order to become stable, it should lose this one electron and complete the octet rule. Only then the valence shell will consist of octet, that is 8 electrons. Now in the next case, if we observe a chlorine molecule, here you can see the chlorine molecule with an electronic configuration of 2, 8, 7. So if it gains one electron, only then it can become stable by completing its octet rule 2, 8, 8. So here there is gain of one electron, whereas in sodium there is loss of one electron. Fine. So now the another configurations are given. Boron, atomic number 5. So 2, 3, valence electron 3. So valence shell or valence shell electrons are nothing but the outermost shell is said to be the valence shell. The outermost shell is said to be the valence shell. Next, Lewis dot structure is the structure that is being given here. So the representation of an atom, a molecule, and its along with its configuration, electronic configuration, with its orbit and shell and valence electrons is known as Lewis dot structure. So here you will represent, so here is a table for representation of Lewis dot structure. So hydrogen is having atomic number 1. So electronic distribution and valence shell is 1. So you will put 1 dot near Lewis dot structure. So in case of helium, which is a noble gas, the atomic number is 2. Electron distribution and valence shell is 2. So you will put 2 dots there. So whereas beryllium is having 2, 2 configuration, but you will consider only the outer shell. So in outer shell you are having only 2 electrons, so 2 dots will be there. Similarly for carbon, the outer shell dots, outer shell dots, outer shell dots. So only the valence shell or the outer shell electron should be considered for the drawing of Lewis dot structure. So if we draw Lewis dot structure for sodium, how it would be? Na single dot, because only one is there, right? But this don't exist actually. This is unstable. Why? Because it is not following the octet rule, right? But we can draw the Lewis structure like this. Now we are going to the types of chemical bond. There are basically 3 types of chemical bond present, that is ionic bond, covalent bond and coordinate bond. So first is ionic bond, which is also known as electrovalent bond. It is the bond formed between the positive and negative ions, the positive and negative ions. So just like a bar magnet, which is having 2 different poles, north and south, where the unlike poles attract each other, similarly unlike charges attract each other. So it's just like the concept of a magnet. So the oppositely charged ions come closer due to the electrostatic force of attraction, thus forming an ionic bond. So similar charges repel each other, whereas the charges which are opposite will attract each other. Fine. So the formation of bond takes place as in this case. If you see, positive ion is cation and negative ion is said to be anion. We can take the example of Na and Cl. So here Na, there is loss of electron. So when an electron is lost, here the sodium atom will become positive and it will form an cation. Positive means cation. So the loss of electron makes that a cation. When an atom loses or gains any electron, it becomes ion, and there are 2 types of ion. The positive ion, when the atom loses an electron, it is said to be positive ion, that is cation, Whereas when an atom gains an electron, it becomes the negative in charge, that is an ion. So any atom which either loses or gains electron is said to be an ion. So when it gains an electron, it is said to be anion. When it loses an electron, it is cation. Fine. Till this it's clear? Okay. Here the chemical bonding is being mentioned. That is, the strongest bonds are ionic, covalent, coordinate and metallic bonds, whereas the weakest bond are hydrogen bond and van der Waals forces.